Thank you everyone for joining us and welcome to the Cancer Research Institute's new webinar series, Breakthroughs in Cancer Immunotherapy. Today is Tuesday, June 4th, 2013. My name is Brian Brewer. I'm Director of Marketing and Communications for the Cancer Research Institute. Cancer Research Institute is a nonprofit organization established in 1953 to support scientific research aimed at harnessing our immune system's power to fight cancer. Over the past 60 years, tremendous strides have been made in understanding the complex relationship between cancer and the immune system. This knowledge, gained through painstaking laboratory and clinical research, has finally led to a new class of cancer treatments called immunotherapy that is revolutionizing cancer treatment today. The Cancer Research Institute has declared June Cancer Immunotherapy Awareness Month. We present this webinar series, 5 in total throughout the month of June, as a way to introduce you to some of the world's top scientists who are carrying out the important research that is leading to cures. Before I introduce today's speaker, I would first like to thank our sponsor, Dendreon Corporation, whose generous support has made this webinar series possible. Now it's my pleasure to welcome our presenter today. Dr. Kunle Odunsi is a leading figure in the development and clinical testing of immunotherapies for ovarian and other gynecologic cancers. He is professor and chair of the Department of Gynecologic Oncology and director of the Center for Immunotherapy at Roswell Park Cancer Institute, the country's oldest cancer treatment hospital, in Buffalo, New York. He is a member of the Cancer Research Institute Scientific Advisory Council and a member of the CRI Ludwig Institute Cancer Vaccine Collaborative, a global clinical trials network focused on immunotherapy. As an MD PhD, Dr. Odunsi works in both the laboratory and the clinic, carrying out important investigative research with real-world clinical impact on cancer patient health. Now, I regret that due to a recording error, we lost 1 minute of Dr. Odunsi's introduction, but then the webinar picks up after that, so I encourage you all to enjoy the questions and answers, and if you have comments, please email us at info@cancerresearch.org after the webinar. Thank you.
That is called debulking surgery. So when these patients first present, we initially perform surgery followed by chemotherapy. Many of the patients go into first complete remission. Unfortunately, more than 70% of patients will ultimately relapse. And once relapse occurs, it is very difficult to cure. In fact, for patients who have what is called platinum-resistant disease, the median survival in general is about 1 year. Consequently, it is critical to develop new strategies such as immunotherapy in order to interrupt the natural cause of this disease. One way to introduce immunotherapy is at this point whereby we tend to minimize the risk of relapse. Another strategy is to introduce immunotherapy up front, and I will try and cover all of these modalities. I want to point out that I'm going to spend a disproportionate amount of time on ovarian cancer because, again, it is the most lethal of all of these gynecologic cancers. Now, the question is, why should we harness the immune system to fight cancer? Why should we do this at all? If you look at the history of vaccination against infectious diseases, bacteria and viruses, we have made tremendous progress. At the turn of the last century, smallpox killed almost 50,000 people in the United States each year. And look at the number of people that die from all of these infectious diseases, such as measles, mumps, rubella, and so on. At the beginning at the end of the last century, however, you can see that the number of people that die from smallpox had fallen to 0, 100% decrease. And look at all of these other numbers here on this right column, that there has been significant and remarkable decrease in the incidence and death from all of these infectious diseases simply because of vaccination. Can we utilize the same strategy in order to decrease the number of patients that die from cancer today? And so a major advance, one of the most significant advances in the last 10 to 15 years, is the understanding that the immune system can protect and eradicate against cancer. Why do we say this? I will show just one example of a study that we did here at Roswell Park, where we looked at immune cells that are called CD8 T cells. If you look at this diagram, these blue cells under the microscope are ovarian cancer cells. The brown staining cells are the immune cells called T cells, CD8 T cells. In patients whose tumors have high numbers of these CD8 T cells, patients along this red line, we find that these patients did a lot better compared with patients whose tumors have low infiltration by these CD8 T cells. In fact, the survival of patients along the red line is almost double the survival of patients along the blue line, 55 versus 26 months. This same kind of data has been shown for other cancer types such as colon, breast, melanoma, and a lot of other cancer types. This kind of results suggest that the immune system is able to mediate regression of tumors, and the presence of immune infiltrates within tumors allow patients to do better. So based on this information, how can we use this information to help patients? But before I get into that, let me quickly do a quick review of how the immune system works. So if you consider the immune system, it is the body's major defense against infectious disease and other invaders. Most of the immunologic cells reside in specific areas in the body, and these are the lymph nodes, these green dots here, the spleen, the bone marrow, the thymus. These are the sites where many immune cells reside. They do travel all over the body to other sites, but these are the primary sites where they reside. So these immune cells patrol the body looking for the bad guys, and these bad guys could be bacteria, viruses, and they are called antigens. But these immune cells are also able to identify cancer cells. When they see cancer cells, they really launch an attack. And the attack is primarily launched by a group of cells that are called lymphocytes. These lymphocytes are foot soldiers. They can be instructed to kill viruses and bacteria and also attack and destroy cancer cells. But they need to be given the proper instruction in the form of vaccines or other modes of immunotherapy. So you have the lymphocytes. The question is, how do you recruit the lymphocytes to recognize the enemy, which are the cancer cells? And what happens after the lymphocytes recognize the enemy? These lymphocytes, these immune cells, utilize a number of approaches. They can make antibodies, and they can also themselves turn into killer cells, soldiers that are able to kill cancer cells or viruses or bacteria. So based on what these immune cells do, immunotherapy approaches can be classified as follows. They can be antibodies. I'm sure many of us are familiar with the use of antibodies for treatment. I've mentioned vaccines, similar to vaccines that are used for infectious disease, almost like getting a flu shot. There can be modulators of immune responses, and some of these are called cytokines. And there are other approaches that are called cellular therapies, especially adoptive T-cell therapy, whereby patients get an infusion of cells, almost like a blood transfusion. And many of these can also be combined. So once we know with this information that the immune cells can recognize antigens, the foreign invaders, what kind of antigens should we then use for cancer vaccines in order to target cancer cells? So there are several possible antigens, and these antigens are simply molecules or proteins that are expressed in the cancer but not in other normal cells of the body. So the best known examples are a family of antigens that are called cancer testis antigens. These antigens are called cancer testis antigens because they are expressed in the testis. This is looking at the testis under the microscope, but they are not expressed in other normal cells of the body because you don't want an antigen to be expressed by normal cells of the brain or heart or stomach because you don't want to cause side effects. But these cancer testis antigens are then expressed in many cancer types, including ovarian cancer. An example of a cancer testis antigen is an antigen that is called New York ESO1 or NY-ESO1. This antigen was discovered in New York at the Ludwig Institute for Cancer Research, initially discovered in a patient with cancer of the esophagus, and is expressed in a wide variety of cancer types. So, coming back to the question of how do you instruct lymphocytes? How do you instruct immune cells to go and recognize, attack, and kill cancer cells? So there are another set of cells within the immune system that are called dendritic cells, as you can see here. These dendritic cells are the professional cells that take up the antigen, such as, again, bacteria, and in this case, NY-ESO1. So the dendritic cell takes up the antigen, it eats it up, and then the next step is that it begins to chew it and put a little piece on its surface here that is then presented to the lymphocytes, the T cells. So once the dendritic cells gives the T cells the antigen, the T cell is happy now, it's activated because it is now ready to go on the attack, to launch an attack. So this T cell is activated, and its primary purpose now is to destroy any cell in the body that expresses NY-ESO1. So the battle begins. So the next step then is, have we applied this in clinical trials of ovarian cancer patients? We have conducted a number of clinical trials as well as others, and these trials have taken different approaches because the first question we wanted to address is what is the best way to give a vaccine against ovarian cancer. So these are different vaccine formulations. You can see we've used something called peptides with adjuvant. We've used protein with adjuvant. We've even used viruses to deliver the NY-ESO1 antigen. Vaccinia, we've used vaccinia virus, fowlpox virus, canary pox virus, all in an attempt to induce very strong immune responses against NY-ESO1 and therefore against the cancer cell. We've also used the dendritic cell itself by manufacturing dendritic cells from patients and using that as a vaccine approach, and I will talk briefly about this. What we have found in all of these studies that I described are the following. Number one, the vaccines are safe. They are well tolerated by our ovarian cancer patients. They are non-toxic. We have found that we can induce antibody and T cell responses in the majority of vaccinated patients. And importantly, and I know this is what everyone is waiting for, we have some initial hint of clinical efficacy. Here's an example of a clinical trial that we conducted using a vaccinia virus to deliver NY-ESO1, that is the antigen, followed by another boost vaccination with a fowlpox virus to deliver NY-ESO1. The rationale for using the viruses is to give the immune system a danger signal to say that there is danger here, therefore you need to recruit the immune cells against NY-ESO1. What we found in this trial of ovarian cancer patients who have completed their surgery and frontline chemotherapy and then were vaccinated in order to prevent relapse or prolong the time to relapse, is that patients along this red line, patients who mounted an immune response, very strong immune response against the vaccine, had very long interval until they developed, until the cancer came back. Remember what we said about the cancer coming back very quickly in ovarian cancer patients. As we expected, patients who did not have strong immune responses, this blue line and the black line, the cancer came back within only about 14 months. So there appeared to be significant prolongation of time to progression, time to disease relapse in patients who mount good immune responses against NY-ESO-1. Our future goal is to further extend this interval, or if possible, to prevent the cancer from coming back altogether. So let me quickly address a couple of other points. One is how do we generate memory cells? Because if you remember this, the cancer eventually came back. How can we train the cells, the immune cells, so that they never forget? Because it is possible that by this time point, which is almost 5 years, the immune cells have forgotten about the cancer, and that's how they were able to come back. Is it possible to use the vaccination and also train the immune cells so that they never forget? So in some studies that we've conducted here at Roswell Park, we treated animals that were bearing tumor with vaccination, and then some of those animals also received a drug called rapamycin. By day 50, the animals that got vaccine plus rapamycin had no evidence of disease. By day 150, these animals continued to survive. If you contrast with animals that did not get rapamycin but got vaccination alone, these animals had low tumor burden by day 50, and later on, all those animals were dead. This study suggests to us that rapamycin might allow these vaccine-induced immune cells to persist, survive for long, and have memory attributes, and therefore prevent relapse of disease. So here is our goal. Even when the cancer is beginning to come back, for the immune cells to be ready to attack and destroy the tumor cells. So let's go on very quickly to talk about some of the newer developments, such as our ability to generate personalized vaccines using those dendritic cells that we talked about previously in order to manufacture the vaccine. What we and others are doing is to take a portion of blood and use the blood to manufacture dendritic cells in a very clean laboratory facility. These dendritic cells are then loaded or pulsed with the antigen, in this case NY-ESO-1, and then given back to the patient. So there are a number of dendritic cell vaccine approaches that are ongoing. Our approach is to, again, use the NY-ESO-1 to put it on the dendritic cells so that when injected into the patient, it can activate the T cells, the lymphocytes. Additional approaches include the use of tumors derived from the patient in order to generate the vaccine. So what we have done is to manufacture these cells in a very clean facility. Here's an example, and these kinds of facilities are present in some institutions. Here's an example from Roswell Park, where the manufacture of dendritic cells is performed under a very rigorous process that allows us to be able to deliver the vaccine back to the patients in a safe manner. In this particular trial, we are using the dendritic cells as well as rapamycin. So patients get the dendritic cell vaccine, 3 injections initially. They get rapamycin along with the injections, and then we wait a while to give a 4th injection in order to determine whether or not these patients will mount a secondary response. This is a test of memory. So the endpoints of this trial are safety and immune responses. but we are very much interested in knowing whether this kind of treatment will also delay the time for the disease to come back. So there are additional approaches that are all under the umbrella of cellular therapies. We've talked about dendritic cell as a form of cellular therapy. The other approaches are called adoptive T-cell therapy for ovarian cancer. These are ongoing at some institutions, and again, there are different types of adoptive T-cell therapy. One of them is called T-cell receptor engineered T-cells. Another approach is chimeric antigen receptor modified T-cells. Some of these approaches are going on at major institutions, including Roswell Park, University of Pennsylvania, Memorial Sloan Kettering Cancer Center, and the NCI. And I'm sure there are some additional institutions that I have not mentioned here. So there are a variety of immunotherapy approaches that include antibodies, dendritic cells, adoptive T cells, all in an effort to destroy tumor cells and prolong the survival of ovarian cancer patients. But what we and others have learned over the years is that the cancer cell doesn't just lay dormant. It begins to utilize some strategies to counteract or escape from immune attack. We have identified some of these mechanisms, and the names that I list here are some of the mechanisms, and these mechanisms are related to what are called immune checkpoints. So antibodies have been developed against some of these immune checkpoints. The ones that are most significant are CTLA4 immune checkpoint, and the second one is the PD-1, PD-L1 immune checkpoint pathway. So blockade of these immune checkpoints is beginning to show significant promise, either by themselves or by combining with vaccination or even combining the different antibodies. So these are all promising areas that are active areas of investigation by us and by other groups. I'm going to spend a moment just to talk about uterine cancers as another type of gynecologic cancers. 1 in 40 women in the United States will develop uterine cancer in their lifetime. There are about 46,000 new cases each year, and about 8,000 women die from the disease each year in the United States. The good thing about uterine cancers is that the majority of patients present with stage 1 disease, unlike ovarian cancer, where the majority of patients present with stages 3 and 4 disease. The modality of treatments include surgery, radiation, and chemotherapy. Immunotherapy for uterine cancers is not quite as advanced as ovarian cancers, but there's a subset of aggressive uterine cancers that behave like ovarian cancers. And we and others are beginning to test whether or not these patients will also benefit from the same immunotherapy approaches that we have designed for ovarian cancer. I would also like to quickly mention about cancers of the cervix, cancer of the vagina, and cancer of the vulva. All of these cancers are in general linked to the human papilloma virus. Fortunately, there has been a vaccine developed against human papilloma virus. This is a preventative vaccine, and there are 2 strategies really to prevent many of these cancers, especially cancers of the cervix and vagina. These are pap smear screening as well as the HPV vaccination. The treatment for these cancers quite often involves surgery and chemoradiation. And right now, immunotherapy, as I said, is mostly preventive immunotherapy, vaccines against HPV to prevent disease in the first place. But once a patient develops cancer, there are attempts to develop cancer vaccines also against HPV in that scenario. At this point, what I would like to do is just to highlight some of the challenges that we and others have faced in developing immunotherapies. The first step, as you can see, is to discover what do you want to target. This requires a lot of scientific investigations, and early studies in academic medical centers. Following the discovery, the question becomes, how do you translate to the clinic? How do we make it available to patients, either in the form of preventing cancer in the first place, preventing relapse of disease, or actually treating patients with cancer? This is a major obstacle. There is a major gap from discovery to translation, and this requires funding by organizations such as the Cancer Research Institute, the NCI, and so on. Not only is there a need for funding, there's also a need for multidisciplinary approach. And hopefully, by taking this approach, it will be possible for these discoveries to then go on to large-scale clinical trial and widespread application. Because right now, most of these discoveries in immunotherapy are restricted to small clinical trials. And it is our goal for the future to bring this to large-scale trials as well as wide availability to all patients wherever they live or reside. And with that, I would like to end by saying that we started a few years ago. Actually, I'm saying a few years, but it's actually more than 50 years ago, just like, trying to learn how to fly. This was one of the Wright brothers in 1901 trying to learn how to fly. By 1906, see what happened. They were able to fly for a few feet or maybe a few miles. Thank God in 2013, we now have these jumbo jets that are able to take us around whereby we can get to any part of the world as quickly as possible. So this is what is going on with immunotherapy. We are not quite there yet, but we've made significant progress over the past 10 to 15 years. And it will continue to take significant support as well as multiple collaborations in order to continue to bring discoveries in the lab to the bedside for wide availability to patients. And with that, I would like to acknowledge, of course, my institution, Roswell Park Cancer Institute, for providing an environment where all of these studies are possible. The Cancer Research Institute and the Ludwig Institute for Cancer Research for just the vision as well as funding support to advance this whole area of immunotherapy. I would also like to thank the Charlotte Geyer Foundation, the Roswell Park Alliance Foundation, and the NIH for funding support to conduct many of the studies that I have talked about, as well as support for other investigators across the country. Thank you very much, and I will take questions.
Great. Thank you, Dr. Odunsi, for that wonderful presentation. We've got a lot of questions in the Q&A, and as you've been going through, I've been writing them down and taking note. There are a lot of common themes in there. So I'll start with just the first question, which is what are the options that are out there now for patients who are in remission from advanced epithelial ovarian cancer? What can a patient do after they've gotten the chemo and the surgery? And if they're concerned about having that cancer come back, what can a patient do?
So the options at the present time are, number one, to do nothing. I generally don't recommend that. So this is for a patient who has completed surgery, chemotherapy, and is in remission. Traditionally, we have done nothing. But we and others believe that, in fact, these patients probably have minimal residual disease that is likely to come back. There has been several studies trying to identify strategies to minimize relapse. One is the use of continuation of chemotherapy. This has not been very successful, and as you know, chemotherapy is associated with significant side effects. The second option is based on some recent trials conducted by the Gynecologic Oncology Group, which is to use a drug called Avastin during the frontline treatment, as well as a maintenance. In other words, the patient is in remission, but you continue to use Avastin in order to prolong the time in remission. The data suggests that the use of Avastin in this way prolonged remission by only about 4 months. So the third option, and this is the option that I favor, is actually immunotherapy approaches for a patient to look for clinical trials. So enroll in clinical trials whereby immunotherapy approaches are being utilized to minimize the risk of relapse or at least prolong the time to relapse. There are several institutions. Many of the clinical trials are available on the NCI website, nci.gov, and these are being conducted across several institutions in the United States at the present
I'd also
time.
like to point out, because that was another one of the questions that I saw numerous people give, which is how to find information about cancer immunotherapy, because it's such a new thing, and a lot of gynecologic oncologists aren't familiar with advances in immunotherapy. They're unable to answer the questions that their patients have. So the first question is, one, where to find those clinical trials. And I'd like to just point out that on the Cancer Research Institute website, we have a cancer immunotherapy clinical trial finder service. And I'll give you the URL right now, and we'll of course also put that, I'll send a message to everyone in just a moment with that link, but the URL is cancerresearch.org/trial-finder. cancerresearch.org/trial-finder. You can speak with an information specialist who can guide you through the process, or you can search the database yourself. We recommend calling the specialist because there are a lot of nuances and a lot of different therapies that are available out there, and it helps to have someone who's familiar with this space to help guide you through that process. Kunle, another question that we had is, which patients are usually eligible for vaccine trials? At what stage does a patient start to look for that trial?
I think the patient should start to look for the trials as soon as a diagnosis is made, even while undergoing the first-line therapies. This is because in many cases, there are a number of eligibility criteria that needs to be met. For example, the trials that we conduct at Roswell Park, in many of the trials, it is important for the tumor tissue obtained from the at the time of surgery to be tested for expression of the antigen. Again, the antigen is NY-ESO1. For patients whose tumors are NY-ESO1 positive, there are a number of clinical trials that these patients can be enrolled on. For patients whose tumors are NY-ESO1 negative, consideration has to be made for with regards to additional strategies, and some of these trials may be available in a locality that is very distant from the patient. So it's important to begin to plan right from the get-go about what kind of trials are available, where are they available, what are the eligibility requirements, and
How
so on.
How important is it for a patient to save samples of his or her, in this case, tumors, for potential screening for future trials? And how does the patient begin that dialogue with their doctor?
I think it's becoming increasingly important for tumor specimens to be banked and stored away at the time of surgery, as well as to be stored, to be preserved in what we call formalin-fixed specimens. So the advantage of that is that many studies can be performed in the future in order to identify the best targets for vaccine and other immunotherapy trials, as well as to identify even additional strategies beyond immunotherapy. Remember what I said. Many times, we will come to the point where we're able to combine multiple approaches. Immunotherapy will be a centerpiece of these approaches, but it's also important to understand additional pathways that may be targeted in that tumor specimen.
We just received a very interesting question. It's one that we sometimes throw around here at the Cancer Research Institute. And what immunotherapy options are available to patients with compromised immune systems?
Yeah, that's a challenging question. I think at the present time, because again, most immunotherapies are conducted as part of clinical trials. Typically, most immunotherapy clinical trials tend to exclude patients with compromised immune system. However, it is likely that in the future, these patients will be tested as a separate category, whereby different types of immunotherapies will be designed for this category of patients, and we will then need to test what is the best way to manipulate the immune system in these types of patients. At the present time, there's little information on how best to immunize these patients, just because they have typically not been included in clinical trials.
Okay. The next question is a question that we commonly get. When people think of the immune system as a weapon to fight cancer, the general public tends to turn to ideas such as nutrition and exercise and healthy living, all the things that we're told to do to stay healthy. What role does nutrition, exercise, and diet, and lifestyle play in keeping our immune system strong? And is there any correlation between healthy lifestyle and cancer development? Or is it that you can live a completely healthy lifestyle and still develop cancer for many number of reasons?
The answer to both of your questions are yes. You can. I think healthy lifestyle, exercise, diet, and nutrition are very important. There is, in fact, a link between, for example, obesity and the risk of several cancers. There's a risk between cigarette smoking and several types of cancers. So healthy lifestyle is critical, not only in the development of cancer in the first place, but also in terms of the outcome of cancer patients. There's a link between nutrition and the immune system. So, for example, there is increasing evidence that adiposity, essentially, people who have large amounts of fat, subcutaneous fat, may have an adverse effect on the function of immune cells. I talked a lot about lymphocytes. The adiposity, which is a reflection of nutrition, may have an adverse effect on how immune cells function, how they travel, how they are supposed to do their job. So, by all means, all of these things, healthy lifestyle, exercise, and diet are important. But I also have to point out that some people live the best lifestyles and yet develop cancer. And this is primarily because cancer is a genetic disease. Sometimes the underlying mechanism is because of a familial predisposition to cancer.
Okay, we're almost out of time, but there are just a couple more quick answers, so I hope we can do these in rapid fire, quick questions. The first one is, are any of these vaccines that you've discussed applicable to prevention? Do we have preventive vaccines yet for ovarian cancer?
The short answer is not yet, but this is something that I'm sure we and others will be working on. There are preventive vaccines for cancer of the cervix, as I pointed out, and that is the HPV vaccine.
What happens if someone has already had their tumors removed but did not have the tissue banked? Is there still a chance that they can receive a vaccine? Is there a way to see if they're eligible for that using their blood or serum?
Absolutely. Usually the tumors are preserved, and there are tests that can be done on even the tumors that have not been banked fresh. There are some tests that can be done on tumors that are banked, in other ways. So if that person will go to the institution where their surgery was performed, they will be able to find out whether there's still a piece of tumor remaining.
Well, that's all the time we have for questions and answers right now. I wish we can go on because there were so many more good questions, but our hope is that we will continue this as a dialogue. We encourage you to come to our Facebook page, at which I'll give you the link later. You can post your questions there, and we can forward them to Dr. Odunsi, and perhaps we can respond to all of them in time. So I ask your patience in that. I'm so grateful that all of you were able to join us, and of course, thank you to Dr. Odunsi for joining us today on this first in our 5-part webinar series of cancer immunotherapy. Before we go, I just wanted to point out next week, on Monday, June 10th, our next webinar will be Engineering T Cells to Conquer Cancer with Dr. Carl June at the University of Pennsylvania in Philadelphia. Dr. June is doing a lot of exciting stuff with those chimeric antigen receptor T cell therapies that Dr. Kunle mentioned. You can register for that at cancerresearch.org/fightwithwhite. Also wanted to point out that our partner 1-800-Flowers is running a special throughout the month of June. You can order flowers from their website at this URL, 1-800-Flowers.com/cancer-research-donation-flowers-and-gifts. You don't have to write that all down. This webinar will be available online after. But 10% of the sale of their white-themed products throughout the month of June will come back to support the work of the Cancer Research Institute, so we encourage you to check out those offers. Again, here are our Facebook, Twitter, and our blog links. You'll be able to access these after the webinar. And one last time, I'd like to thank our generous sponsor, Dendreon, for making this webinar series possible. Thank you very much. If you want to learn more, you can visit our website at cancerresearch.org/fightwithwhite. White represents the power of immunotherapy to conquer all cancers and all the cancer awareness colors combined. That's white. So thank you very much for joining us today. And with that, we conclude today's webinar. Thank you, Dr. Odunsi. Thank you, everyone.